Okay, so um, the way that chemists generally prefer to express concentration is in the form of molarity. Molarity. Do you know what molarity means now, Fred? Moles? No. Not funny. Okay, sorry. Big M, molarity means, oh, moles per liter. That's right. It means moles per liter. Moles of what? Solute. That's right. Per what? Liter of solution. Very good. So big M, molarity is the general way that chemists prefer to express concentration. However, it will be expressed in a variety of different ways depending on your conditions, settings, the laboratory, the job that you're in, whatever it is. And so we have to be flexible. We have to have that flexibility. Okay? So one way that concentration can be expressed is in terms of mass percentage. Mass percentage. So we have the mass of our solute divided by the mass of solution, and then we multiply by 100, and that gives us the mass percent. So for example, if I had 10 grams of sodium chloride and 100 milliliters of solution, and let's say the density of it was 1, so it's 100 grams of solution. All right, I could take the mass of the solute divided by the mass of solution times 100, right? And then that would give me my mass percent. So 10 divided by 100 times 100, and that would give me 10%. 10 or times 0.1. So let me throw in the times 100 here. Give me 10% sodium chloride in that solution. So that's another way to express concentration. All right. So if we see something that says it's 7.4% sodium hypochlorite by mass, 7.4%, right? I could identify its concentration. That means that it's 7.4 grams of sodium hypochlorite and NaOCl for every 100 grams of solution. All right. I could also express it in terms of volume percent. Volume percent. So, meaning this is usually done when your solute is a liquid. So, for example, if I have 70% alcohol, IPA, isopropyl alcohol, that's the alcohol that we generally buy, the rubbing alcohol that we buy at the store or at the pharmacy. 70% isopropyl alcohol means that there's 70 milliliters, this is now in volume, because alcohol is a liquid at room temperature, right? So 70 milliliters of isopropyl alcohol for every 100 milliliters of the solution. And times 100, that gives me 70% isopropyl alcohol. Or yeah. Okay. We can also have a mass volume percentage. That's what we just expressed. And here's an example. Physiological saline solution used to prepare IVs has a concentration of 0.9 mass per volume, indicating that the composition is 0.9 grams solute for every 100 milliliters of solution. Okay, so here's a couple other examples. Another example here of how scenarios where concentrations are expressed differently. And then parts per million is another way that concentration can be expressed. Now, parts per million is a little bit difficult for students to kind of grasp initially, even though it says right in the words, the name of it, parts per million. You know, it's the mass of the solute for every million mass units of the solution, right? Parts per million. Um, the best way I find for young students to gather this is to just memorize, and we're not going to be using it very much moving forward, but to memorize that 1 part per million is equal to 1 milligram per liter, 1 milligram of solute per liter of solution. So for every part per million, you have that many milligrams per liter of solution. Now, the reason that works is because a liter of solution is equal to 1,000 milliliters of solution. And 1,000 milliliters of solution, if this is an aqueous solution, is going to have be 1,000 grams, because the density of aqueous solutions is generally going to be 1 gram per milliliter. So for 1,000 milliliters, you have 1,000 grams of solution. So 1 part per million is 1 milligram of solute for every 1,000 grams of solution. 1,000 grams can be expressed in milligrams, and that ends up being 1,000,000 milligrams. For every 1 milligram of solute, there's 1,000,000 milligrams of solution. Okay, good. So that's where you can see our 1 part per million is 1 unit solute for every 1,000,000 units solution. Okay, good. That's a beginning. When it comes time to talk more about parts per million, we will. Excellent.